system of ODs, like this system of ODs contains only first order. There may have some system of ODs which contains second order also, y1 double dash, y2 double dash, or it may contain three dependent variables like y1, y2, y3. Okay, but in your syllabus only this type of system of ODs you have two variables, two dependent variables y1 and y2, and both are of first order derivatives. So we are going to solve this type of system of ODs. So how to solve it? There have actually several process to solve this system of ODs. In matrix method, we can solve it by reducing it to second order OD. We can solve it, but here we will solve the system of ODs by using Laplace transform only. Okay. So to solve by Laplace transform, some initial conditions should be given along with the system of ODs. So we are assuming that the initial conditions are y1 0 is equal to some k1 and y2 0 is equal to some k2. Okay. So mainly we will solve a system of ODs with initial values. मतलब पहले एक इनिशियल वैल्यू प्रॉब्लम सॉल्व किए थे, अभी साइमल्टेनियसली दो इनिशियल वैल्यू प्रॉब्लम सॉल्व करेंगे. टेक्निक एक ही है. we will apply Laplace transform on both of the equations and then we will solve. See, I'm giving you a summary how to solve, then I will take an example and show you in details. So what we will do, we take Laplace transform. Laplace transform on both of the equations. Okay, on both of the ODs I can write. So then fast OD reduced to this type, something into y1s plus something into y2s equals something, where y1s and y2s are what? y1s means Laplace transform of small y1 and y2s means Laplace transform of small y2. Okay, so that equation is coming from the first. Okay, and second, from the second equation also you will get this type of equation, something into y1s plus something into y2s is equal to something. From the first we will get this, and from the second you will get this. After that what we will do, these two are basically what, system of linear equations. ये last दो जो equation है, these are system of linear equations. So you can solve it by any methods, like method of elimination or method of substitution, whatever method you know. You solve these two. So on solving you will get what, y1 is equal to something and y2s is equal to something, right? Now taking Laplace inverse, after that what you will do, take Laplace inverse of y1s, that will give you small y1t, and take Laplace inverse of capital Y2s, that will give you small y2t. So taking Laplace inverse, we will get y1t, which is the Laplace inverse of y1s, and y2t, which is the Laplace inverse of y2s. Okay, that y1 and y2 together is called the solution of the system of OD. Okay, whatever you got after taking Laplace inverse, that y1 and y2, these two together is called what? The solution of the system of ODs. Do you get it? The process, the method.
Yes.
Okay, now I am showing an example. Let us take an exercise problem. So 2 to 15, but here problem number 11, 12, 13, these are second order. So you can ignore it or you can solve it also. Same way, same process. मतलब 2 to 10 में जो फर्स्ट ऑर्डर सिस्टम ऑफ ओडीज है उसमें उसमें कोई डिफरेंस नहीं है. ओनली डिफरेंस क्या होगा 11 12 13 में? बस ये y1 डबल डैश का फॉर्मूला लिखना पड़ेगा. लैपलास ट्रांसफॉर्म ऑफ y1 डबल डैश, लैपलास ट्रांसफॉर्म ऑफ y2 डबल डैश, ये फॉर्मूला नया है. बाकी तो वही सेम टू सेम सिंप्लीफाई करेंगे तो y1 एंड y2 का दो लीनियर इक्वेशन मिल जाएगा एंड सॉल्व करने से y1s y2s मिल जाएगा. देन लाप्लास इनवर्स लेने से y1t y2t मिल जाएगा. So only you practice 2 to 10, that will be enough. Uh, okay, I am showing problem number 8. Y1 dash is equal to minus 2 y1 plus 3 y2, y2 dash equals 4y1 minus y2, 4 and 3, 3. Okay, so we have to solve this by Laplace transform. Now see, you compare with the standard form. Uh, Here G1t and G2t means only function of t. Have there any? ये जो दोनों इक्वेशन है इसमें क्या फंक्शन ऑफ टी कुछ है? मतलब सेपरेटली एडिशन नहीं है, राइट? मतलब इसमें G1t एंड G2t जीरो है दोनों में. तो अगर कोई फंक्शन ऑफ टी लाइक ई टू द पावर टी या साइन 2t ऐसे कुछ अगर टर्म रह भी जाता तो मेथड कोई भी चेंज नहीं होता, मेथड में कुछ भी चेंज नहीं होता, राइट? यू टेक लैपलास ट्रांसफॉर्म देन यू सिंप्लीफाई. ये रहे या ना रहे मतलब प्रोसेस में या मेथड में कोई भी डिफरेंस नहीं है. यहाँ पे फॉर दैट पर्टिकुलर प्रॉब्लम इसमें नहीं है. देखो मतलब जैसे ओनली y1 एंड y2 ही है. But I can show you some problem which contains that G1t and G2t. Like problem number 5, you see y1 dash is equal to y2 plus this. तो ये जो 1 plus this ये G1t है. Similarly second 1 minus ut minus 1 ये G2t है. ठीक है, तो ऐसे G1t G2t कुछ भी रहे उसका लैपलास ट्रांसफॉर्म पता होना चाहिए बस. Now see how I am solving. So taking Laplace transform on both of the equations. So Laplace transform of y1 dash equals to minus 2 Laplace transform of y1 plus 3 Laplace transform of y2, and second equation Laplace transform of y2 dash equals 4 into Laplace transform of y1 minus Laplace transform of y2. Okay. Next you apply the derivative formula. What is the formula? Laplace transform of y1 dash. Do you remember? S into y1 s minus y1 0. Right? Laplace transform of f dash. What is the formula? S fs minus small f 0. Same thing. I'm writing.
Yes, sir.
Here, what is capital Y1 S? Y1 S means Laplace transform of small y1. Usual notation जो है. And I will use another notation y2s, that is Laplace transform of small y2. Here y1 and y2 both are function of t. Okay. So right side what I write? Minus 2 y1s plus 3 y2s. And second equation s y2s minus y20 equals 4 y1s minus y2s. Okay. Now y10 and y20. These are initial conditions. So you put these values y10 and y20. So s y1 s minus 4 equals minus 2 y1 s plus 3 y2 s, and second is y2 s minus 3 4 y1 s minus y2 s. Now you write the similar terms together, like y1 is, you write all the terms related to y1 is together and y2 is separately. So it will be what? If I write y1 is from the first, then it is s plus 2 into y1 is s plus 2 into y1 is minus 3 y2 is equals that 4, you move it to the right side, plus 4. Okay. And second, minus 4 y1 minus 4 y1 is s plus 1 y2 y2 s equals 3. Do you get it? This form how I have written.
Yes.
Okay, now see, as I told at the beginning, after simplification we will get something into y1 s plus something into y2 s is equal to something, and another also in that form. So are we getting that? Something into y1 s plus something into y2 s is equal to something, second also in the same form, right? Now what we will do, we have to solve this. So solve it. Here y1s and y2s are the variable. So you have to find what is y1s and what is y2s. Okay, so you can take this as variable and solve it. I am denoting it as equation number 1 and equation number 2. So uh, if we eliminate y1, then what we need to do? 1 into 4 and 2 into s plus 2, right? I am doing this. इक्वेशन 1 को 4 से मल्टीप्लाई करो, इक्वेशन 2 को s प्लस 2 से मल्टीप्लाई कर रहा हूँ। मैं देख रहा हूँ कि y1 s कैसे एलिमिनेट होगा। तो तुम अपना और कोई मेथड अप्लाई कर सकते हो, ठीक है। तो 4 इंटू एस प्लस 2 y1s minus 12 y2s equals 16, and secondly minus 4 into s plus 2 y1s plus s plus 1 into s plus 2 y2s equals to 3 into s plus 2. Now we will add these two equation. We will add these two equation. Then y1 will be eliminated, and rest you simplify and find y2. So it will be s plus 1 into s plus 2 minus 12 y2s equals 16 plus 3 into s plus 2. So you can simplify it. Y2s will be it will be 3s plus 22 divided by simplify s plus 1 into s plus 2 minus 12 a square 3s plus 2 to a square plus 3s minus 10. That is our y2s. Now by using that y2s you can you can find y1s. You just substitute that y2 in any of 1 and 2, you will get y1, right? So I'm substituting 3 in 2, तो क्या हो जाएगा -4 y1s plus s plus 1 into y2 3s plus 22 divided by a square plus 3s minus 10 equals 3. Therefore minus 4y sorry, y1s equals 3 minus s plus 1 s plus 1 3s plus 22 divided by a square plus 3s minus 10. Now simplify and find what is y1s. Minus 4 into y1s, it will be what? 3 square 9s and 30, and 3 square cancel out 25. 25 is 9s, so minus 16 is, and it is 22 30 minus 30 minus 22, तो क्या है -52. Just check the calculation. 3s plus sorry minus, therefore y1s equals divided by -4, so 4s plus 13 divided by a square plus 3s minus 10. So we got y1s and y2s. Now you take their Laplace inverse to find y1t and y2t. So from okay, say it is 4. So I am finding first the Laplace inverse of y1s. Okay. I'm assuming that 4s plus 13 divided by a square plus 3s minus 10. 4s plus 13, if we can factorize it, is plus 5 into s minus 2 equals a divided by s plus 5 plus b divided by s minus 2. Okay. I'm using method of partial fraction to make it simple. So 4s plus 13 equals a into s minus 2 plus b into s plus 5. Now you put s equal to 2, then it will be 8, 13, 21, 7. So b will be 3. You put s equals minus 5. Minus 5 means minus 20 to minus 7 equals what? Minus 7a. तो a हो जाएगा 1. Therefore, that 4 can be written as, therefore, y1s, a means 1. So 1 by s plus 5 and b means 3. 3 by s minus 2. So taking Laplace inverse, what we will get? y1t is equal to Laplace inverse of 1 by s plus 5 क्या होगा?
e to the power t.
And for the second, this, right? 3 to the power 2t. So we got y1t. Now y2t I need, which is the Laplace inverse of y2s. That means from equation 3, we will get y2t. So now from 3, y2s equals what? 3s plus 22. 3s plus 22 divided by a square plus 3s minus 10. Let 3s plus 22 divided by a square plus 3s minus 10 equals to 3s plus 22 divided by s plus 5 into s minus 2 equals to s minus 2 equals to what? A divided by s plus 5 b divided by s minus 2. So which implies that 3s plus 22 is equal to a into s minus 2 plus b into s plus 5. Now you take s equal to 2, it will be what? 28, 7b. B is equal to 4. And you put s equal to minus 5, minus 15 plus 22, 7, and this side 0 minus 7a, a minus 1. Therefore, y2s equal to a divided by s plus 5. That means minus 1 by s plus 5 plus b means 4. 4 divided by s minus 2. Taking Laplace inverse y2t is equal to first part this and second part this. Finally, you write the solution. Therefore, the solution of the system of ODs is y1t. You just write them together, y1 and y2, y1t e to the power minus 5t plus 3 e to the power 2t and y2t minus e to the power minus 5t plus 4 e to the power 2t. Say, is it clear? कैसे करना है?
Yes, sir.
Yes.
तो डिफिकल्टी लेवल में भी मतलब हाई और लो, कभी कभी ये y1s एंड y2s जो है वो थोड़ा कॉम्प्लिकेटेड हो सकता है, तो लैप्लास इनवर्स निकालने में टाइम लगेगा, बट द प्रोसेस इज सिंपल. गिवन द इक्वेशन, you take Laplace transform on both of the equation, then you solve the equations related to y1s and y2s to get y1s and y2s, then you take Laplace inverse to get y1t and y2t. Okay, so I have shared handwritten notes in the WhatsApp group. You may find more problems on that system of ODs. Okay, so that's all about Laplace transform. Now I will start Fourier series. Okay, any doubt? Tell me any doubt in Laplace transform?
No, sir.
So we are going to start a new chapter named Fourier series. Uh, I think it is chapter number 11. I did not remember exactly, but maybe from the textbook you search, it is chapter 11. Otherwise, in the next class, I will tell. Okay. Now, देखो series means it is some means that relate sum of a few terms, a few or sum of many terms. You know, you have studied power series, so it is not exactly power series. So Fourier series, it is one kind of infinite series. So let us see the definition of Fourier series. So you just read it. Fourier series are infinite series that represent periodic function in terms of cosine and sines. तो Fourier series में क्या करते हैं? Basically we represent a periodic function in terms of sine and cosine series. Okay, मतलब fx एक अगर पूरी एक fx एक अगर पीरियडिक फंक्शन है तो fx को साइन एंड कोसाइन के टर्म पे लिखना एज एन इनफाइनाइट सीरीज, तो वो फूरियर सीरीज है. तो इसका एक पर्टिकुलर फॉर्मूला है, यू कैन सी, but before that we should know what is periodic function and we should know some basic integral formulas. Okay, I'm not going details about the periodic function because earlier you have studied periodic function, when a function is called periodic and what is the period of a function, right? Do you remember or forgot periodic function? Tell me. देखो कोई भी कुछ नहीं बोल रहे हो. Am I audible?
Yes, sir.
Okay, I'm telling you in brief. So a function fx is called periodic if f of x plus p is equal to fx for some positive real p. Okay, that is the mathematical definition of periodic function. And you know several periodic function like sin x, cos x, tan x. Most of the trigonometric functions are periodic, right? Like fx equals to sin x. It is periodic. Do you agree? It is periodic because if you calculate this x plus 2 pi, it is what? Sine of x plus 2 pi, which is nothing but sin x. That means fx. So what we are getting that f of x plus 2 pi is equal to fx, and that 2 pi is the smallest positive real number for which this happening, right? Therefore, fx is equal to sin x. It is a periodic function, and that p is called period. No, you should remember to be a period, it should be smallest and positive. मतलब कोई भी ऐसे p मिल गया जिसके लिए f of x plus p is equal to fx हो रहा है, that p may not be a period. What is the criteria to be a period? The value should be smallest and positive. Okay, I think here I have written p is the smallest. It is not written. Okay, not an issue. p should be smallest. मतलब ऐसे ये जो देखो sin x के लिए अगर p को तुम 4 पाई फिक्स करोगे मतलब f of x plus 4 पाई, then also it will give you what? Fx. F of x plus 4 pi is equal to fx. Then should I call 4 pi as period? No, because उससे छोटा है जो ये प्रॉपर्टी होल्ड करता है. It should be smallest positive real number. Fine. Now some other examples of periodic function like cos x, tan x. Okay, x minus floor of x. It is also one kind of periodic. Maybe many of you don't know x minus floor of x. It is periodic. देखो, usually trigonometric functions are periodic, but if someone asks, you tell me a periodic function which is not trigonometric. So in that case, you should remember this x minus floor of x. It is called fractional part. In 10 plus 2 level, many of you have studied this notion. x माइनस बॉक्स x, मतलब तुम जो 10 प्लस 2 लेवल में पढ़े थे उसमें नोटेशन था ऐसे x माइनस बॉक्स x, उसको सेकेंड ब्रैकेट x में लिखते थे. डू यू रिमेम्बर?
Yes, sir.
So it is called fractional part, and if you draw the graph, it is repeated, means that its graph is repeated in finite intervals. इसका ग्राफ कैसा होगा x माइनस बॉक्स x का? अगर याद है तो ऐसे टाइप का ग्राफ होता था, देखो, राइट. So what we can see that a part is repeated in each interval of equal length. If this happens for a function, then that function should be periodic. So here x minus that floor of x, it is periodic with period what? What is the period? Can you tell me? The period is 1. X minus box x का period जो है, that is 1. Can you tell me what is the period of mod of sin x? We know that the period for sin x, it is 2 pi. But if the function is mod of sin x, what is the period? Period is pi. ये बोलना चाहिए, ये अगर नहीं बोलोगे तो कैसे होगा? Now if I take fx equal to sin x by 2, can you tell me what is the period?
Pi by 2.
Pi by 2. You are telling pi by 2. So if I write f of x plus pi by 2, then it is can it be f of x? You check sine of uh, x plus pi by 2 divided by 2. That means sine of x by 2 plus pi by 4. Can I write it as sine x by 2? No? Right, so it is not pi by 2. Think. Look, usually what is the period for sine x? 2 pi. So you can assume 2 pi. मतलब होगा कि नहीं, वेरीफाई कर लो. तो if I write f of x plus 2 pi, what it will be? Replace x by x plus 2 pi. Then it will be sine x by 2 plus pi, na? So it is not sine x by 2. Then 2 pi is also not a period. Actually, it is 4 pi. It is my suggestion, please all of you follow that part which you have studied in 10 plus 2 level related to that periodic function, because sometimes question comes from that period and periodic function. MCQ question, मतलब long question तो नहीं आएगा, but MCQ related question आता है periodic function and period related. इसका actually period होगा 4 pi. You can check f of x plus 4 pi is equal to fx. So period is 4 pi. Now another example. Actually, I am telling all possible way. If fx is like sine 2x, then what is the period? Can you tell me? You check that f of x plus pi is equal to fx. However, the what? However, the period for sine x is 2 pi, but sine 2x if I write, then it is actually not 2 pi. It is pi. Okay. Any doubt here?
रेशियो कितना है तेरा?
क्या हुआ?
यार तेरे तो सही आए होंगे, मुझे पता है.
कौन बोल रहा है?
बी में कितना मिला है?
ये कहाँ पे है रितिका? ओके, टेल मी एनी डाउट रिलेटेड टू पीरियड? अगर है अभी तो मैं क्लियर करवा देता हूँ.
No, sir.
But I suggest please you read the textbook where that periodic function is included, is there. 10+12 में पढ़े हो कि नहीं? था या नहीं?
सर याद नहीं सर.
याद नहीं है?
नो सर.
ठीक है, तो पढ़ लेना थोड़ा. मैं तो
ये सर
आइडिया
क्योंकि
दे
सर
दिया
12
हूँ.
बहुत पहले छूट गया.
ओके, now let us come to the Fourier series representation for a periodic function. Okay, that is the main thing here in that chapter. Given a function fx, if it is asked to write the Fourier series representation, what is the formula you see? Look, first of all, we are assuming that fx is a period. Sorry. Okay. First of all, we are assuming, means here we are assuming that fx is a periodic function with period 2 pi. Later on, we will generalize the fact. We will consider any arbitrary period. But at first, we are assuming fx is a periodic function with period 2 pi. Then, what is the Fourier series representation of fx? You see. So, Fourier series representation of this function fx is given by, देखो, here two things are important, the function and its period. Okay, उसके हिसाब से ये सीरीज लिखा जाता है, पीरियड के हिसाब से. तो if the period is 2 pi, then the Fourier series representation of fx is equal to a naught plus summation n1 to infinity an cos nx plus bn sin nx. Okay, so if you write some terms, if you write explicitly the series, then देखो एक एक टर्म्स में क्या क्या कंटेन है, मतलब एक एक टर्म्स आइदर उसमें साइन एक्स है और उसमें कॉस एक्स है, राइट. इफ यू एक्सपांड द सीरीज, क्या लिखूंगा, ए नॉट प्लस यू पुट एन इज इक्वल टू 1, सो a1 cos x प्लस b1 sin x प्लस a2 sin 2x plus b2, sorry, a2 what, cos 2x plus b2 sin 2x and so on. So we are writing a series which contains sines and cosine terms only. Okay, so it is the form, it is the Fourier series form for a function a naught. You have to remember this form, this form. Okay, a naught plus summation n1 to infinity an cos nx plus bn sin nx. Now ये तो arbitrary form है. Here what are the unknowns? a naught, an and bn. ये क्या है हम लोगों को पता नहीं है. And these a naught, an and bn, these are called Fourier coefficients. So what is our task? Our task is to find the values of these coefficients. अगर ये values मिल गया मतलब we have determined the series completely, right? जैसे वो पावर सीरीज में करते थे ना, मतलब वो कोएफिशिएंट का रिलेशन निकाल के फिर कोएफिशिएंट्स सब्स्टिट्यूट करते थे तो लास्ट पे आंसर आता था. यहाँ पे भी वही कोएफिशिएंट्स जो है उसको डिटरमाइन करना है, ए नॉट, ए एन एंड बी एन, ये तीनों कोएफिशिएंट्स को, not 3 actually, a naught it is 1 and a n there are infinitely many a n matlab a1 a2 a3 a4 a5 and bn means b1 b2 b3 b4 b5 b6 and so on. तो ये सब coefficients निकालना है. These are called Fourier coefficients. Okay. So what are the formula? You see, these are the main things in the Fourier series representation. First you write the representation, then you write the formula to find these Fourier coefficients. So देखो formula for a naught, it is 1 by 2 pi minus pi to pi fx dx. Okay, you have to remember all these three formula. A naught is equal to 1 by 2 pi minus pi to pi fx dx. An equals to 1 by pi minus pi to pi fx cos nx dx, and bn 1 by pi minus pi to pi integration fx sin nx dx. क्योंकि ये जो फंक्शन है उसका पीरियड 2 पाई है, इसके लिए ये सब पाई रिलेटेड आया है. ठीक है, ये जो लिमिट है वो भी पाई रिलेटेड है. अगर ये 2 पाई अलावा और कुछ होता तो उसके हिसाब से ये लिमिट, इंटीग्रेशन का लिमिट भी चेंज हो जाता, एंड ये cos nx sin nx ये nx भी चेंज हो जाता है. वो कैसे कैसे चेंज होगा अकॉर्डिंगली, दैट आई विल शो यू लेटर ऑन. बट हियर फॉर 2 pi period, that these are the formulas. Okay, if the period is 2 pi, then the Fourier series representation of fx is this, and where the Fourier coefficients can be obtained by this formula. देखो a naught के लिए एक फॉर्मूला, a n के लिए अलग फॉर्मूला. Okay, and b n के लिए.
Yes, sir.
In some book, you may find the Fourier series representation in that form. fx equal to a naught by 2 plus as it is. वो कुछ कुछ बुक में a naught by 2 भी लिखा हुआ है. तो वहां पे क्या चेंज किया है ना, ये a naught का फॉर्मूला में ये वाला 2 नहीं है. तुम देख सकते हो कोई भी बुक में अगर a naught by 2 लिखा होगा, वहां पे a naught का फॉर्मूला में यहाँ पे जो 1 by 2 पाई था वो 2 पाई, मतलब वो 2 नहीं है. मतलब अल्टीमेटली वो सेम टू सेम है ना, a naught by 2, ये 2 कट जा रहा है. तो यू कैन रिमेम्बर ओनली वन फॉर्म. ये दोनों में कंफ्यूज मत हो जाना, कोई भी एक फॉर्म को याद रखना. इन योर टेक्स्ट बुक आई थिंक द फॉर्म इनिशियली आई हैव शोन, दैट इज द गिवन वन, fx equal to a naught plus this, not a naught by 2. तो देखो बेसिकली क्या करना है, यू हैव टू सॉल्व सम इंटीग्रेशंस, 3 इंटीग्रेशंस. ये एक है minus pi to pi fx dx, सेकंड minus pi to pi fx cos nx, third minus pi to pi fx sin nx. These 3 integration you have to solve. Now these are some essential integral formulas which are needed in this calculation of Fourier coefficients. मतलब ये Fourier coefficients निकालने के टाइम पे कभी-कभी ऐसे फॉर्म आ जाता है, known form. So if you remember this form, then it will be easier to calculate. Okay. So what are the basic integral formulas? ये याद रखना जरूरी है. इंटीग्रेशन माइनस पाई टू पाई साइन एम एक्स, मतलब साइन एम एक्स का इंटीग्रेशन करेंगे माइनस पाई टू पाई. ये इंटीग्रेशन तो कर ही सकते हो, मतलब 2 मिनट में हो जाएगा, राइट. तो करके देखो, वैल्यू जो है वो 0 आएगा. बट इफ यू रिमेम्बर डायरेक्टली तो मतलब वो 2 मिनट भी तुम्हारा बच जाएगा कि साइन है और लिमिट में माइनस पाई टू पाई, मतलब उसका इंटीग्रेशन वैल्यू 0 है. डायरेक्टली ये पुट कर दी. सिमिलरली cos minus pi to pi integration, that is also 0. Next, product of sin mx and sin nx, two different sin function. Okay, मतलब एक में m है एक में n है, sin mx and sin nx. Integration minus pi to pi, it is pi into delta mn. That delta is not direct delta. Do you know delta mn definition? It is equals to 1 if m is equal to n and 0 अदरवाइज। ओके, ये डेफिनेशन है डेल्टा एम एन का। तो ये क्या बोल रहे हैं कि साइन एम एक्स एंड साइन एन एक्स, इसका इंटीग्रेशन अगर एम एंड एन इक्वल हो गया तो अल्टीमेटली क्या हो जाएगा, आंसर हो जाएगा पाई, राइट? क्योंकि डेल्टा एम एन क्या है, 1, एम इज इक्वल टू एन केस में। तो इंटीग्रेशन माइनस, लाइक ये वाला इंटीग्रेशन सिंपली सॉल्व करके देखो, माइनस पाई टू पाई साइन 2x साइन 3x, ये डिफरेंट केस लिया मैंने। इसका वैल्यू क्या आएगा अकॉर्डिंग टू दैट फॉर्मूला?
0.
0। यू कैन वेरीफाई इट ऑल्सो। एंड अगर दोनों ही साइन 2x होता तो उसका वैल्यू हो जाता पाई, मतलब माइनस पाई टू पाई साइन स्क्वायर 2x, ऐसे आ गया, वैल्यू ऑफ दैट विल बी पाई। सिमिलरली अगर ये दोनों इंस्टेड ऑफ साइन अगर कॉस हो गया, that is also pi into delta m n. That means if m not equals to n, the value of the integration is 0, and if m is equal to n, that is not mn, that is mx. So if m is equal to n, then the value will be pi. And if we take mixing, mixing means sin and cos का product, ये sin sin लिया, ये cos cos लिया, ये दोनों का नेचर सेम ही है, इंटीग्रेशन का वैल्यू जो है वो सेम टाइप। बट अगर मिक्सिंग ले लिए, साइन वन साइन अनदर कॉस, इसका लिमिट जो होता है वो 0। व्हाट इज द रीजन? बिकॉज दैट फंक्शन इज व्हाट, ऑड फंक्शन। यू नो इवन फंक्शन, ऑड फंक्शन? f of minus x is equal to minus fx, then fx is called what, odd. And if f of minus x equals to fx, then even.
Even.
And there are some properties na related to integration for even and odd.
Yes, sir.
Integration minus a to a fx dx. If fx is odd, then what is the value of this integration? 0. And if fx is even, then what is the value of this integration? We cannot find directly the value. We can write this integration 2 into 0 to a, right? That is for what, even case, and ये 0 value odd case. So sin mx and cos nx, it is an odd function. You can verify it. It is an odd function. Therefore, minus pi to pi integration 0. Fine. So better to remember these 5 integral formula. अगर याद नहीं भी रखोगे तो मतलब ये इंटीग्रेशन सॉल्व करने के लिए 2 मिनट 3 मिनट टाइम लगेगा कुछ नहीं। If you think that it is overburden to you, then don't remember.
Okay, sir.
You need to calculate these things. So in the next class, we will take a function fx and we will find its Fourier series representation. Okay.
Yes, sir.
So, okay, that's all.
थैंक यू सर।
सर
Thank
आ
you,
गया
sir.
सर मैथ्स मार्क्स।
ये सब मार्क आ गया सर।
मैथ्स का मार्क्स आ गया कब
यस
आया?
सर।
अभी आया।
अभी आया सर।
ओके, चेक करो। Fine, I will give all present. Thank you all.
Thank you, sir.
थैंक
थैंक यू सर।
हेलो हेलो।
हेलो सर गए क्या?
सर चले गए।
कितने मिले मैथ्स में?
पता नहीं, चेक नहीं किया।
करना भाई।
जितना भी मिला होगा ठीक ठाक ही मिला होगा।
ठीक ठाक ही मिला है।
10 से ऊपर तो आया ही होगा, इतना तो गारंटी है।
10 के ऊपर, 15 के ऊपर भी है।
तेरा कितना है?
भाई
पहले तू बता।
पहले तू बता।
17।
15।
और कोई?